Good afternoon, viewers. In the previous videos, we have been discussing about form measurement, fundamentals of form measurements, threading measurements, gauge measurements, and applications of those threading measuring instruments. All those things we have been discussing in the previous videos. Now, in the present video, we are going to discuss about gear terminology, gear measuring, straightness measuring, parallelism measuring, and their advantages and applications of those measuring instruments and measuring technology. If you look at this slide, this is a straightness measurement. We are thinking that whatever we are training from the lathe or from the milling or from any machine tool will be of good straightness. But if you look at the workpiece, it looks like a straightness, but actually it may have some errors. The profile may be slightly up and downs. The up and down may be of 0.001 millimeter, that is 1 micron. It's not of much, but if you look through the measuring instrument, as we are seeing here, that is stylus we are having, that will move up and down, and it will be connected to the another device that will give you the reading. So that is, we can draw the graph as we are seeing the resultant profile. This is called straightness measurement. Similarly, look at this parallelism. It is a single side parallelism. In the next slide, we will be seeing double side. Here also, by using the stylus, we are moving up and down, and we are checking that it is not parallel. The error is there. Spindle axis and the outermost contour layer, that is circumferential contour layer, is different by 1 or 2 degrees. So that can also be measured by using this method. This is double side we are measuring of cylinder, and we are finding that the error in a circumferential error. So the parallelism is not there. Even for cylinders, we have this much error. If you are going to make the gears with the manufacturing of gear tooth, gear hopper, by using the machine called gear hopper, or in shaper also we can do. Mostly we will be doing the gear hopping machine to generate the gear teeth. For making the cylinder itself, we have found the straightness and the parallelism. Some minor error. Look at the formula for finding the parallelism: D1 minus D2. Maximum error minus minimum, that gives the parallelism error. That is, parallelism is not perfect. It may be of 0.001, that is 1 micron. But that is negligible if it is within the tolerance limit. Even for cylindrical rod, we are measuring the parallelism and the straightness. Why don't we measure for gear? That is the question arises. That's why we have gone for gear teeth measuring and checking the terminology of gears. Mostly we will be discussing about spur gear. So now look at this pitch measurement. As we have seen in the threaded, here also we have the pitch. We are having pitch measuring machine, tool maker's microscope, and screw pitch gauge in condition of the threaded. So this is called the pitch measuring machine. Now look at this. For thread, I am putting this for thread. Similarly, we will be having for gear also. The stylus, this part is a stylus. This part is known as a stylus. This is pointer. This is a carriage, and a spring loaded head. Visual indicator, that is, and this is micrometer. This is a screw thread. By means of stylus, we are measuring the reading. This pointer will move, it will like deflect. This is called pitch measuring machine. Another one is the tool maker's microscope. Workpiece is placed on the base of the instrument. The optical head is mounted on a vertical column. It can be moved up and down. Likewise, like a microscope, workpiece is mounted on a glass plate. A light source provides horizontal beam of light, which is reflected from a mirror by 90 degrees upwards towards the table. So now look at this picture. You will understand how the tool maker's microscope will be looking. This optical head, this is called optical head. This is a table. This is a micrometer screw for longitudinal movement of the table. This is a micrometer screw for lateral movement. This is for lateral movement. This screw for longitudinal movement. This one is a supporting column. This is a clamp screw. It looks very similar to the shaping machine, but it is very similar to microscope, tool maker's microscope. See, now in the next slide also we are looking at the different view. From here we will be looking at this, and here we will be having the reflector mirror. Through this reflector mirror, the rays will be falling on the object. That is the object what we are going to measure. Here we have the mirror. Here we have the collimator lens. This hollow base, that is different. That is a column hollow base or the measure tool things. That's not directly related with the tool microscope. That is robust machining purpose. That is for holding the workpieces. We have some robust arrangement. That's all. This is the optical head. It is also working in similar way of autocollimator. The collimator lens will parallel the beams. From the lamp, the rays are falling on the mirror. From mirror, it gets reflected, and through the another reflector, we are viewing through the eyepiece. Then we will do the calculation and we will find the pitch. See here, look at this toolmaker's microscope, how it is going to work. The applications are to measure the linear measurements, measurement of pitch of the screw, measurement of pitch diameter, measurement of thread angle, comparing thread forms, center to center distance measurement. For all these things, we can have this form of tool microscope, toolmaker's microscope. Now look at this. This is a screw pitch gauge. Here we are having the pitch like threaded. So by using this, we can easily measure the pitch of the screw. Here they have put the mark 19G, 20G likewise. Flank angle measurement. See, this is gear measurement. A spur gear, helical gear, racket gear. These are the known things. Here it is a spur gear. If the teeth is parallel to axis of rotation, it is called a spur gear. If the teeth is inclined into the axis of rotation, it will be called helical gear. The gears are used to transmit power from one shaft to another parallel shaft. If you want to transfer the power to the perpendicular shaft, we will be using bevel gears. Mostly the gears are used in electric screwdriver, oscillator sprinkler, wind alarm clock, washing machine, and other domestic usages. This, as I have told, helical gear which is having inclined teeth. This teeth is inclined, but parallel to each teeth. This is for power transmission. It is better than a spur gear since the angle of contact and the contact surface is more in the case of helical gear. This is a rack and pinion arrangement to convert the rotary motion into linear motion. Look at this animation. The steering system in cars. Okay. This is a straight and bevel gear for power transmission through 90 degree. This is the terminology of spur gear. So with this I will stop and we will go to the